Hey everyone, this is Winter Code, and today we're going to look at some Solidity smart contract hacking. So if you're not familiar, the thing that's on my screen is this really cool set of challenges that OpenZeppelin has put out called Ethernaut. And it is basically a set of war games or hacking challenges where you're given smart contracts that have some sort of vulnerability in them, and the goal is to figure out what the vulnerability is and how to exploit it. If you're familiar with the concept of war games, this goes kind of way back. Back in the day, there was this website, I used to play this in college all the time, called Over the Wire. And these are all different servers that have a bunch of different levels on them. And I think, what was the one we used in college? Vortex. Yeah, so Vortex has all these different levels. Like this one, for example, you have to create a special tar file, which will exploit this C program. This one has to do with like password collisions, it looks like. So that's kind of where this concept of war games comes from. And then Ethernaut is basically that, but applied to Solidity. So what I want to show you today is we're going to play this level. It's called Telephone. It is really, really straightforward. The code is not super big, as you can see down here. It's just a contract with an address of the owner, the constructor, which sets the owner to the whoever is like basically deploying this contract. That's why you have message sender here. And then there's this one function called change owner. You give it the address of this underscore owner, and it's checking to see if the transaction origin is not equal to the message sender. Then it's going to go ahead and update the owner of this contract. But is basically we need to become the owner of this contract in order to win. But we can't call this change owner directly, because if we are trying to become the owner and we call this change owner directly, then message sender is going to be equal not only to ourselves, but it's also going to be equal to tx.origin. So this if will fail, like this will be false, and this owner equals underscore owner won't get executed. So we need to find a way to call this change owner function in such a way that the transaction origin is not the same as message sender. A blog post on this where I was just talking about the differences between tx.origin and message sender. But to give you a quick summary, and we're going to see this here in a second, when you have a chain of smart contract calls, so like the EOA, the externally owned account, calls contract A, which calls contract B, which calls contract C, let's say. In the scope of contract C, message sender is whatever called it, so contract B. And then in the scope of contract B, message sender is whatever called it, so it's contract A. And in contract A, message sender would be the address of this EOA. However, at all points in this transaction, tx.origin always points to the EOA that initiated the transaction. In order to beat this level, if you're not familiar with Ethernaut, it's pretty cool. You just go to the console, you say, give me a new instance. I am going to hop in here with my Sepolia test network account. And now I've got my instance address. So this instance address down here is an instance of the smart contract which was deployed on the Sepolia test network, which means that I can start sending requests to it and trying to hack it. Which you can see here if I say contract, I think it's .address. Yeah, so those two match. This is the address of the deployed contract, and then this is my Sepolia test network account. If I do something like await contract change owner, and just give it the address of myself, which is player, this is not going to work. I'll still pay for it because I'm trying to send a transaction across the network. But what's going to happen is change owner is going to get called, and we're going to see that message sender is, you can't really see the execution here, but it would be my address, and then tx.origin would also be my address. Yeah, we can see the owner is not, in fact, myself. So, oh well. We need to get a little bit more clever. Going back to this little diagram here, we can see like right now we have a situation where I'm the EOA and I'm calling the deployed contract. So message sender and tx.origin are both going to point to my address. But it looks like if I could just add one kind of contract in between myself and the contract that I'm trying to attack, then in, say, contract B, message sender would point to contract A, but tx.origin would actually point to the EOA, which is my address, which is exactly what I want to do. So I'm going to hop over to Remix, and I have some code up already, and I'm just going to walk through it real quick and then deploy it, and then we're going to beat this level. We're going to store the address of the deployed telephone address contract, which we'll do here in a second. And then I have this awesome function down here called win, and all it does is it basically creates like an interface instance here, and then it calls the change owner method on that, and it's going to pass through msg.sender, which is in this case going to be the address of the EOA, as the parameter to change owner. Because you can see here, when tx.origin does not equal to message sender, we're actually setting the owner of this smart contract to whichever parameter _owner was passed through here. And I need to make sure that that's my address, because I need to become the owner of this contract in order to beat this level. We are going to come over to deploy. We're going to deploy my contract. You can see in Remix it's asking for the constructor parameter, which is telephone address. So I'm going to come back up here and copy this contract address. And then I'm going to put it in here, and I'm going to say deploy. And I actually made a mistake. I need it to not go to this Remix VM. I need it to actually go on the proper Sepolia test network. So I need to use the injected provider, MetaMask. It's on Sepolia. Gas prices are high, but we'll take our chances anyway. So now my contract was deployed. If I hit this win button here, I'll actually beat the level. But I just want to walk you through real quick what's going to happen. So my contract is deployed, and it's going to call the deployed telephone contract when I call function win. So if I come back to here, I am the EOA. This is my address. My contract with the win function is contract A, and then it's going to interact with contract B, which is the telephone contract, the one that I have to beat to win this level. So in contract B, message sender is going to be whatever the address of contract A is, but tx.origin is going to be my address. I come over to Remix, I hit win. I have to pay for it, of course, because we're sending a transaction across the blockchain, and this one's actually going to update state. Cool. So if I'm not mistaken, this is my address on the test network. You can see here this 278 something 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 6D88, and then this 2C2307 was the previous address, which is what we see here. So now when I say contract owner, it should be my address. It is. So I am now the owner of that deployed contract. I've beat the level. If I click submit instance, we're going to see a little bit of fanfare here. Cool. And so yeah, that worked. So that is it for myself. Thank you for watching, and I will catch you next time.